So last class I was discussing about areas of parallelogram and triangles. From that chapter I was discussing about figures on the same base and between same parallels. That is exercise number 9.1. I was talking about figures on the same base and between same parallels. So from there, exercise 9.1, I have solved one question for you, and I hope you have tried the remaining questions by yourself. Now I will tell you one more question from that particular exercise, exercise 9.1. Exercise 9.1. I will tell you one more question from that particular exercise. One figure is given on the book like this. So this is the figure. Along with that, one triangle is inscribed. So here ABCD is a parallelogram. ABCD is a parallelogram. ABCD is a parallelogram, and along with that, PQR is one triangle. PQR is one triangle. So here in this case, ABCD is a parallelogram, along with that one triangle is there, PQR triangle. We have, if we see these two particular figure, look at these two figure. These two figure is on the same base and between same parallel or not. The question is like this: it is in the same base and same parallel or not. Now if we see the base BC, so for the parallelogram, BC is the base, and for the triangle, PQ is the base. Okay, so PQ is the base and BC is the base for the parallelogram. Now these two figures, the triangle and the parallelogram, lies between same parallel. Lies between same parallel. Between same parallel. Between same parallel. AD and BC. AD and BC. AD and BC are the two parallels, lies between same parallel but not on the same base. Look at the same base here. This is the base BC. Here the base is not same because from P to Q the base is different and BC is the different base, but not on the same base. So this is the question. ABCD is a parallelogram and PQR is a triangle. ABCD parallelogram and PQR triangle lies between same parallel but not on the same base. Why not on the same base? Because you see here BC base, while PQ is not exactly matching with BC base. So this is how we have to solve the questions like this. So the remaining question you try to solve it. Next today I am going to explain one important theorem from the next exercise. The theorem is, I'm going to explain about it and going to prove the theorem as well. The theorem is, the next theorem is theorem number 9.1. It is in your book only. Theorem number 9.1. The theorem is theorem 9.1. The theorem is so we are already familiar with figures on the same base and between same parallel. And the theorem is parallelograms on the same base and between same parallel are equal in area. Parallelograms on the same base and between the same parallel are equal in area. The theorem is parallelogram between the same base and between same parallel are equal in area. So I will draw the figure for you. Parallelogram on the same base and between same parallel. So let me draw two parallelograms. Let me draw two parallelograms. One parallelogram, this is one parallelogram. I will name it ABCD. ABCD. ABCD is one parallelogram, and one more parallelogram I will draw along with that. So that ABCD is clearly ABCD is a parallelogram. Next I will draw one more parallelogram here from point D. So D, this one I will extend this line and the parallelogram. So two parallelograms are there on the board. In the figure, two parallelograms are there. One is ABCD, another one is starting from D. We can take it D, or else we can say CDEF. These are the two parallelograms. Two parallelograms ABCD and CDEF. These are the two parallelograms lies on the same base CD. CD is the same base, and between same parallel CD and AF. So these are the two figures lying on the same base and between same parallels. Now what I have to prove? I have to prove that area of ABCD is equal to area of CDEF. That is what we have to prove. So first thing is, I will do the proof part for you. Proof. So how to do the proof? Very interesting one and very simple one. So first observe the figure properly. Two parallelograms are there on the same base and between same parallel. So here two parallelograms are there. Parallelogram. So given parallelogram AB CD, parallelograms ABCD and CDEF lies on the same base, lies on the same base, lies on the same base CD and between, so between, I have written shortcut, between same parallel and between same parallel, between same parallel CD and AF. CD and F. To prove. So what to prove? We have to prove area. So in place of area, I will write AR. AR means area. Area of ABCD. Area of ABCD is equal to area of CDEF. So these are the two equal areas. That means parallelogram on the same base and between same parallel are equal in area. That is what we are supposed to prove. So in this case, area of ABCD is equal to area of CDEF. That's what we need to prove. Now let's see how do we can prove this. Let me explain how we can prove this one. So let me start the proof. So proof part. First you can see here, look at ABCD. A, B, C, D and C, D, E, F. So here in this case, if you see here, one triangle is there. This one, clearly we can see this is one triangle. A, D, E is one triangle, and here also you can see here, this is one triangle. That is B, C, F. So first part is, in our proof, the first part is, very first part is, we have to show that these two triangles are congruent. First part of the proof is, we need to show that triangle ADE is congruent with triangle BCF. That's what we need to do at the very beginning. So we need to prove that we need to show that these two triangles are congruent first. So we have different congruence rules. I hope you have studied already. You have studied in chapter number 5 in triangles. So various congruence criteria are there, rules are there. By using that, we show that, I will show you that these two triangles are congruent. So let me explain about that. So first part is, I'm going to repeat again. First part is, we need to show that these two triangles are congruent. So what I will do in triangle ADE and triangle BCF. These are the two triangles. I have to show it congruent. That's why I have taken the two triangles. I have written the name of the two triangles. Now let me see. Let's see what are the things. We already are familiar. Last class I have discussed about the various properties of parallelogram. In a parallelogram, the opposite sides are equal. Opposite angles are also equal. So this you can see here, AD side and the BC side will be equal. Why? Because AD side is in parallelogram ABCD and BC side is also in parallelogram ABCD. These are the two opposite sides. So very first step, I can write AD is equal to BC. Why AD is equal to BC? I have to write the reason also. Why it is equal? Opposite sides of parallelogram. Opposite sides of opposite sides of parallelogram ABCD. So sides equal. Then you see this particular line, that AF line is parallel to CD line. AF line is parallel to CD line. If we see AF line is parallel to CD line, so here in this case, this particular angle will be equal to this particular angle, corresponding angles. Now I will show you separately how corresponding angle. Look at here, this line and this line are two parallel lines. These two lines are parallel lines. If I draw one transversal here, suppose this is the transversal. So corresponding angles will be equal. What are the corresponding angles? So this is the parallel line and corresponding angles will be equal. Okay, so these are like this only. These are, you can see here, this line and this line parallel. This line and this line parallel. This is the transversal. So this particular angle and this particular angle will be equal because corresponding angles here, this angle and this half angle will be equal, corresponding angle. Whereas this side and this side are parallel. So I will write next angle AED. AED is equal to angle BFC. BFC. The reason why I should write the reason AD parallel BC, comma AF transversal. AD parallel, sorry, not AD, this one, DE parallel, DE line is parallel to CF line because CDEF is also parallelogram. So DE and CF will be parallel because this is opposite sides of parallelogram. So DE parallel CF, comma DE parallel CF, comma AF transversal. AF transversal. AF transversal. Transversal corresponding angles. So I can write AF transversal corresponding angles. So I can write corresponding angles. So these two are equal. Next, AED is equal to BFC. After that, again we can see here this angle is equal to this angle. Apart from that, once more you see here this line is also parallel to this line. Okay or no? Then this angle will be equal to this angle. This angle will be equal to this angle. Why? Because this line and this line parallel. This is the transversal. Say, I will show you here. This AD line and BC line parallel. This is the transversal. So this angle will be equal to this angle. Altered corresponding angles. So I can write DAD angle DAD is equal to angle CBF corresponding angles. Both are corresponding angles. Corresponding angles. So both are corresponding angles. Now in this triangle, this particular triangle, these two angles are equal. So in a triangle, if two angles are equal, then third angle will be automatically equal. Third angle will be automatically equal because sum of all three angles is 180 degree. Suppose this angle is 60 degree, this angle is also 60 degree, then automatically the third angle will be 60 degree. That means in a triangle, if two angles are equal, then third angle will be automatically equal to each other. So that is what, since A angle is equal to angle this one, and this AED angle is equal to this F angle. So I can write automatically ADE angle. Therefore I can write angle. So right here. Therefore I can write. Therefore angle ADE is equal to angle BCF. So this triangle will be equal. Now you see here, this A angle is equal to this B angle, that is CBF angle. Next, this side, AD side is equal to BC side, and this ADE ADE angle is equal to BCF angle. Now by using angle side angle rule, I can say that these two triangles are congruent. Therefore, I can write triangle ADE is congruent with triangle BCF angle side angle rule. Angle side angle rule. How? This angle, this particular A angle is equal to this particular CBF angle. Then ADE angle is equal to BCF angle. Then the between the side in the angle, the side AD side is inscribed within these two angle. So this side is equal to this particular BC side. Already I have written previously on this, so we can write these two triangles are congruent by using angle side angle rule. Now, since the two triangles are equal triangles, since the two triangles are congruent, so what I can write? Congruent triangles, they will have equal area also. So from here on I can write area ADE is equal to area BCF. So since the two triangles are congruent, therefore their areas will also be equal. Now further I will proceed the next step. After showing that their two triangles are congruent, then their two areas will also be equal. After that, next part you see, that is very interesting, how to prove the next part. So the next part is, see how I will write. Next part I will write this one, ABCD, parallelogram ABCD can be written as, so I will write here, area ABCD is equal to, area ABCD means, ABCD I can break it into two parts. You see here, one triangle and the other one is the remaining part, this particular part. So how I will write, see, area ABCD is equal to, I will write area ADE, I will write ADE plus, along with AD, what should I add? BCD, if along with AD, if I add BCDE, this part I prove, add these two parts, you will get ABCD. So area ADE plus area BCDE. So if I combine these two parts, I will get ABCD. Now I have already shown it that area ADE is equal to area BCF. So in place of ADE, I will write area BCF plus area BCDE. So now you see here, BCF, look at where is BCF? BCF means this particular part, this part. BCF, along with BCF, if I add BCD, BCD is this part. Along with BCF, if I add BCED, if I write BCED, then what I will get? If I write BCDE, let me just correct on BCDE, then what I will get? I will get CDEF. If I add these two, I will get area CDEF. That is what we are supposed to prove. Area ABCD is equal to area CDEF. Hence it is proved. So I hope you understood. If you have any doubts, you can ask me. So these are the various steps that I should follow. Like once again, I am repeating how to prove. That is, the theorem is parallelograms be on the same base and between same areas are equal in area. Now how to prove this? First part is we have to draw the figure, two different parallelograms which will be one on single base and between same parallels. After that, what I have to do? I have to show these two particular triangle congruent. Once I showed it congruent triangles will have equal areas, then I can write these two triangles have equal areas. After that, I will write ABCD. Area ABCD means here total two figures are included. One is triangle along with this quadrilateral. So I have separated into two parts, that is area of triangle plus area of the quadrilateral. Now in place of AD, I can write BCF. So while BCF I am going to add with BCD, I will get completely CDEF. That is what we are supposed to prove. Thanks a lot. Thank you.